The diagram below shows a curve in the plane. Explain why the curve does not represent a function. Is it possible to make the curve represent a function by restricting the domain, and give a reason? So this is our x-axis, this is our y-axis, and this is the origin, the point 0, 0, and this is our curve. So explain why the curve does not represent a function. The curve does not represent a function as there are vertical lines which do not intersect the curve, and other vertical lines which intersect the curve more than once. So if this vertical line, let's say it's crossing our x-axis at x equals minus 5, we can see that it does not intersect with our curve. If I was to move it to the right of my y-axis, let's say that this was positive 5, x equals positive 5, I can see that it's intersecting my graph in two places. So it cannot be a function because with an x value of, let's say for example 5, it is intersecting my curve in two places. And with an x value of, let's say for example minus 5, it is not intersecting my curve at all. So it cannot be a function. So is it possible to make the curve represent a function by restricting the domain, and give a reason? By restricting the domain to x is greater or equal to 0, x is an element of or, the real number set, we remove the lines which do not intersect the curve. So that means moving our straight line anywhere to the right of the y-axis. So at this point we would have x is equal to 0. So moving it to x is equal to 1, x is equal to 2, x is equal to 3, and so on. Then we are removing the lines which do not intersect the curve. So when we had our line on the left of the y-axis, any of these points of any of these x values did not intersect our curve, whereas on the right hand side of the y-axis they're intersecting our curve at two places. So by restricting the domain to x is greater or equal to 0 and x is an element of or, the real number set, we remove the lines that do not intersect the curve. However, we cannot remove the lines which intersect the curve more than once. Thus, it is not possible to make the curve represent a function by restricting the domain. So what this means is, if we have x values, or inputs, or domains, whichever you'd like to call them, of x values less than 0, then anywhere that we draw in our vertical line, we do not intersect our curve. Whereas if we let our x values or our domain be greater than 0, greater or equal to 0, then anywhere we draw our vertical line, we are intersecting our curve in two places. So neither of those options are a function. So there is no domain that we can use that this will be a function. So the question asks, is it possible to make the curve represent a function by restricting the domain, by restricting the x values or the inputs? And the answer is no. It's not possible to make this specific curve into a function.